One of the contributing factors to arrhythmia is the formation of heart blocks, which are structures, usually scar tissue, that impede the transfer of electrical signals throughout the heart. The formation of heart blocks is problematic, considering that there are other sites in the heart located outside of the SA node that also contain pacemaker cells. These sites are called ectopic foci. Under normal conditions, the action potentials from the SA node suppress the action potentials of these ectopic foci. This is because the SA node has a higher frequency of depolarization compared to them. When a pacemaker cell is being depolarized at a higher frequency than its intrinsic rate by the SA node, more sodium ions enter the cell per unit of time. The increased concentration of sodium ions increases the activity of the sodium-potassium ATPase of the cell, causing it to expel more sodium ions in exchange for potassium ions. In doing so, it generates more hyperpolarizing currents that drive the cell membrane potential to become more negative. This counteracts the pacemaker or funny current of the cell and therefore stops any spontaneous generation of action potentials. In this action potential graph of a pacemaker cell, the funny current is the current that gives rise to phase 4. In the end, the rate of depolarization of these ectopic foci becomes predominantly driven by the SA node. When heart blocks are present, however, the cells in the ectopic foci do not receive action potentials from the SA node. Thus, there's no stimulus to increase their sodium-potassium ATPase activity and, by extension, to increase the generation of hyperpolarizing currents. This lack of stimulus allows the pacemaker cells in the ectopic foci to generate action potentials of their own. These action potentials subsequently influence nearby cardiac muscle cells, causing them to contract independent of the rhythm set by the SA node. This could give rise to arrhythmia.